Hi there. In this video today we're going to be talking about graphing quadratic functions. We're going to do it based off of a table of values. First, let's just go over what the general formula of a quadratic function is. So it follows the line of ax squared plus bx plus c. The a, b, and c can be any numbers except a cannot be 0. And the thing that matters is that that square has to be there and it has to be the largest index number. In the most simple case of our quadratic function, this is what it'll look like. This is just y equals x squared. You should notice the curve of the line. We don't use straight lines with it. It has to be curved. And it can be opened up upward like it is in this one, or it can actually be going downward. The name of this graph is a parabola. Let's get started on our first example. We're going to graph y equals x squared minus 1. I know that this is a quadratic function because it has that x squared value and there isn't any other index number that's larger than 2. Then from here, I see this table with values for x from -2 to 2. I'm actually going to be substituting those values in to solve for y. So the first one, I've got x is -2, so I'm going to replace the x with -2. So it becomes y equals -2 squared minus 1. Notice I put the brackets around the -2 because I want to make sure that I'm including the negative in my square value. The -2 squared becomes a positive 4. Take away 1, so my first y value is just 3. We just need to repeat that for the rest of the x values. So you're going to substitute in -1 for x, 0 for x, 1 for x, as well as 2 for x. You should notice a pattern in our y values that we get. They start to repeat because there's going to be some form of symmetry, which we'll see in the graph. To actually graph our function, we're going to be looking at the vertical pairs of our x's and y's. So if you look at it, -2 and 3 is a pair, -1, 0, and so on. So you're going to just plot the coordinates from the vertical pairs in our table. The last step of actually graphing this function is to connect all of our points together. You want to make sure your line goes to the edge of the grid as it is on this one, as well as that you have a curved graph, just like it was in that first example of a parabola that we saw. When graphing quadratic functions, you need to make sure that your graph looks right because you can have marks taken off just for having a sloppy graph. So make sure your lines are smooth, you're not feathering them, so it's just one consistent line. And also it's not flat at the bottom, it has to be a curve. And if your graph looks wrong, you may have miscalculated something. A quadratic function will have either a minimum point or a maximum point. You can tell where it is because it's where it's turning. There's going to be a minimum if the graph is opening up, and then a maximum if the graph is opening down. Going back to our first example, we want to determine if it has a maximum or minimum point, and then what the coordinate for that point is. So first, this graph is opening upwards, so we know that it's going to be a minimum point. We actually can also say that there's nothing below the point, so it must be the minimum. Then we can just say it's where it's turning, which is at 0, -1. As I mentioned earlier in this video, there is symmetry in a quadratic function. So there's an axis of symmetry, which is just a vertical line that would go through the maximum or minimum point. It kind of splits the parabola in half, so all the points on the left side could actually be reflected onto the right side. Our answer is always just going to be x equals a number. Looking back at our first example one more time, we're going to find the axis of symmetry now. So the axis of symmetry is just the x value of our minimum value. So in this case, our minimum value is at 0, -1, and the x value is 0 for that. So that means our axis of symmetry is just x equals 0. Let's move on to our next example where we are graphing y equals -x squared plus 2x plus 1. When you substitute the -2 in, notice that I still have a negative outside of my brackets because it was outside of that x before. So you do actually have to be careful with the negatives here because that original negative is not in the squared value. When we square the -2, it becomes 4. However, there was also a negative in front of it, so it's actually going to still be a -4. That's only going to happen when we have the negative outside of the brackets as well. Then 2 times -2 is just -4, plus the 1, so we get an answer of -7 for our first x value. Now we just have to repeat that for our x values of -1, 0, 1, and 2. Again, just being careful with that negative value in front of the x squared. Again, just do that, simplify to get all of our y values. To graph it again, we're going to look at the vertical pair. So the first one is -2, -7. As you can see, that's actually off the grid, and when we have something off the grid, we don't have to draw it. We'll just move on to the next one. So then you plot all of the points, and you will connect them with a curved line. The last thing we're going to do in this example is to find out the maximum or minimum point as well as the axis of symmetry. So we can see that our parabola is opening downwards, so we're going to have a maximum point. As we can see, it's that top point at 1, 2, so our maximum is just at 1, 2, and that means the axis of symmetry is x equals 1. That's all for this video. If you have any questions, then either leave a comment on Show My Homework or send me an email, and I will get back to you as soon as I can. Thanks!